Why is the sky blue? That's a fascinating question. It's one of nature's most beautiful optical phenomena, Sale.
Sunlight looks white, but it's actually made up of many different colors.
Each color of light has a different wavelength. Red is the longest. Violet is the shortest.
When sunlight travels through the atmosphere, it collides with tiny air molecules.
This scattering makes blue light bounce in every direction, much more than other colors. Because blue light scatters the most, the whole sky around us appears blue. Without the atmosphere, the sky would be pitch black, like it is on the moon.
At noon, sunlight travels the shortest path, so the sky looks deeper and clearer blue.
At sunset, sunlight travels farther, scattering away the blue, leaving only reds and oranges.
So the blue sky is the magic of sunlight, air, and a touch of physics. Sunlight enters the atmosphere and meets billions of tiny air molecules.
Rayleigh scattering happens when light hits particles smaller than its wavelength.
Blue and violet light have short wavelengths, so they scatter more strongly than red.
Violet scatters even more than blue, but our eyes aren't very sensitive to violet light.
Plus, the ozone layer high above absorbs most of the violet light.
Together, these effects leave mostly blue light scattered into our eyes.
Scattering sends blue light from all directions, making the entire sky glow evenly.
If Earth's atmosphere were thicker, the sky would look darker and bluer.
On Mars, where the air is thin, the sky looks pinkish-orange instead of blue.
The blue sky exists because blue light scatters the most in Earth's atmosphere.
Actually, violet light scatters even more than blue.
But human eyes aren't sensitive to violet, so we don't see a purple sky.
The ozone layer also absorbs most violet light before it reaches us.
That's why blue dominates Venture's. It's what our eyes perceive most strongly.
If humans could see violet better, the sky might look slightly purple. Some animals can see more violet shades than we can.
So the color of the sky isn't fixed ephemeral. It depends on how our eyes interpret it.
Human vision sees only a small part of light, in verito, the range we call visible light.
Color doesn't truly exist. It's how our brains interpret light waves.
The sky isn't purple because our eyes favor blue. Color is perception, not just physics.
When the sun is low, sunlight passes through thicker air. Blue light is scattered out, leaving red and orange hues to reach our eyes. Dust and smoke in the air make sunsets appear even redder.
After rain, clean air scatters blue light more fully, making the sky bright and clear. At noon, sunlight goes straight, giving a deep blue. At sunrise, longer paths turn it pale and golden.
Higher altitudes mean thinner air cavity. The sky turns darker, then almost violet black.
Polluted air scatters light irregularly, making the sky dull and grayish.
In the mountains, the air is clean and thin,
Zoom in. The sky shines a deeper blue.
Near the ocean, moist air scatters light evenly to red, creating a soft, pale blue horizon.
The color of the sky changes with sunlight, dust, and the clarity of the air. The blue sky is a perfect balance between sunlight and air.
Without light, there's no color. Without air, there's no blue sky. The blue sky shows that science can explain beauty prudy and still leave us in awe.
To a child, the sky is just blue. To science, it's a wonder of nature.
Blue brings calm at Fried, like the earth itself breathing peacefully. A simple phenomenon that reveals the elegant workings of the universe.
The blue sky reminds us, Fried, we're all small parts of a vast natural world.
White light to Rayleigh scattering, to human eyes, to blue sky.
Understanding physics doesn't take away beauty. It helps us appreciate it more.
The blue sky, our first lesson in light, perception, and the wonder of the universe.